Hello children, welcome to my channel. Today's topic is similarity, chapter number 15, part 1 of class 10. Okay, so let's start. This chapter is similar to congruency of class 9. Okay, so I'll start with congruency, then I'll move to similarity. You have studied about congruency in class 7 and in class 9. Okay, and congruency means shape and size. Two objects are said to be congruent if they have the same shape and the same size. So here we have to look at both shape and size. Okay, for that reason we use the symbol equal to for size, then this symbol for shape. Okay, so this symbol is used in congruency. Okay, in congruency we look at shape and size. Now we have similarity. In similarity, size is not important, simply shape is important. Okay, so two objects are said to be similar if they have the same shape. Okay, only shape. So which symbol will be used here? Obviously this one. So remember, when two objects are similar, you have to use this sign to show that they are similar to each other. Okay, when two objects are congruent, you have to show this sign, use this sign. Okay, so from this, can we say that the objects which are congruent are similar? Yes, we can say, because if two objects are congruent, then their shape is same, size is same. Okay, and if shape is same, then they are bound to be similar. So remember, congruency implies similarity. Means if two objects are congruent, they are bound to be similar. But is the converse true? If two objects are similar, then the shape is same. We cannot say anything about the size. The size may be same, may not be same. So can we say that they are congruent? We cannot say, because to be congruent, besides the shape, we have to look at the size also. The size should also be same. Okay, but here if two objects are similar, simply the shape is same. We cannot say anything about the size, so we cannot say that they are congruent. Okay, so remember, congruency implies similarity, but similarity doesn't imply congruency. The converse is not true. Okay, so let us take some examples of similar objects, similar figures. If we take two circles, okay, you can see the size is different, but the shape is same. Okay, so we can say they are similar. In fact, all circles are similar. Remember this. All circles are similar. Next, first I am taking plane figures, then I will move to solids. Okay, I have taken an equilateral triangle. Now I am taking another equilateral triangle. They are also similar because the shape is same. Okay, means if you magnify this small one, you can get this one. So we can say these two equilateral triangles are also similar. In fact, all equilateral triangles are similar. Now let us take two squares, one small square and one big square. Each angle is 90 degree. I have not shown. You can see these two squares have also the same shape. Means if you magnify this small square, you can get this big square. So again these two squares are similar, or all squares are similar. So in this way you can take various examples of plane figures. Now let us move to solids. Okay, 3D. If you compare a tennis ball and a football, okay, a tennis ball and a football, both have the same shape. The size may be different, okay, the size may be different, but the shape is same. Both are spherical in shape, so we can say they are similar. So remember, all spheres are similar. All spheres are similar. If you take two cubes or of different size, suppose if you take a Ludo cube and you take a Rubik's cube, a small cube and a big cube, they may have different size, okay, they may have different surface area, may have different volume, but their shape is same. Both are cubical, so they are also similar. So remember, all cubes are. So in this way we can continue. There can be infinite examples of similarity between two figures or two objects. Okay, I have given some. Okay. So from this you can understand that the concept of similarity can be used in plane figures. Okay. Also it can be used in solids. Okay. So similarity is a vast concept. It can be used in plane figures also. It can be used in solids also. But we are going to study about plane figures only that two triangles only. So we will focus on triangles. Okay, only triangles and nothing else. Okay. If we move back to congruency of triangles, which you have studied in class 9, if two triangles are congruent, then what happens? The corresponding angles are equal, okay, and the corresponding sides are also equal. We get these two things. If two triangles are congruent, then corresponding angles are equal, corresponding sides are also equal. But in case of similarity, what happens? If two triangles are similar, okay, if two triangles are similar, then first we get corresponding angles equal. Okay, so corresponding angles are equal. Why? Because the shape is same. Okay. Second, size may be same, may not be same. We cannot say. Okay. Don't think that if size is same, then they are not similar. Okay. If size is same, then they are similar also and congruent also. Okay. But if size is different, then they are simply similar. Okay. So let us go for the size. Size may be same, may not be same. So we cannot say that the sides are equal. We can say that the sides are proportional. So corresponding sides are proportional. Okay, Okay, remember these two important points. When two triangles are similar, corresponding angles are equal, corresponding sides are not equal, they are proportional. Okay, let us take an example to understand this. This is not only for triangles. These 2 points can be used for quadrilaterals also, means squares. Okay, it can be used for pentagons, hexagons, etc. Okay, in solids also it can be used. But since we are in triangles, so we will limit ourselves to triangles. So let us take an example. Triangle ABC is similar to this sign is given. Okay. To show that their shape is same, only shape. Suppose triangle ABC is similar to triangle QPR. It is given, suppose. Okay, I am drawing the two triangles. Suppose this is A, B, C. My diagram may not be accurate. Q, P, R. Okay. So these two triangles are similar. The order is given. You cannot change the order. Okay. A, B, C, Q, P, R. A, B, C, Q, P, R. So first point was corresponding angles are equal. So we can get first point. Angle A is equal to angle Q. Angle B is equal to angle P. Angle C is equal to angle R. Means this angle is equal to this angle. This angle is equal to this angle. And this angle is equal to this angle. Okay, you have to follow this order. This order is very important. Randomly you cannot say angle equal angle R. Okay, you have to follow this order. Second point is corresponding sides are proportional. We cannot say that corresponding sides are equal, they are proportional. Means AB by QP 1 to 1 2. AB by QP is equal to BC by PR 2 3 2 3 is equal to AC by Q1 1 3 1 3. AC by Q1, and this is a constant represented using the letter K, small k, which means scale or proportionality factor. Okay, so you get everything from this order. So remember, here order is very important. Okay, corresponding angles are equal, corresponding sides are proportional. This k can be any value, but it cannot be 0. Okay, first thing, it cannot be 0 and it cannot be negative. It has to be greater than 0. Okay, so not 0, not negative. Okay, it can be any positive real number. Okay, any positive real number. Now we will move to different postulates to prove which we are going to use to prove similarity. Okay, in case of congruency there were some postulates like side side side. Okay, side angle side, angle side angle, angle angle side, and right angle hypotenuse side, RHS. There were 5 postulates in case of congruency. In similarity there are 3 postulates. The first postulate is angle angle, and it is the most important postulate. Okay, because it is frequently used. It is the easiest also and the most frequently used postulate. This means if two angles of a triangle are equal to two angles of another triangle, then they are similar. Okay, just that. So let us draw two triangles. A, B, C. Suppose P, Q, R. So it is given that two angles of this triangle are equal to two angles of this triangle. Then they are similar. Suppose let us take angle B is equal to angle Q. Okay. Then let us take angle A is equal to angle R. Okay. So you can see two angles of this triangle are equal to two angles of this triangle. So they are similar. So how to write this? In triangle ABC and triangle PQR, just like converse. Okay, you are already acquainted with converse. How to write means how to use the postulate. Just in the similar way, you have to use similarity. In triangle ABC and triangle PQR, angle A is equal to angle R. This is given. Okay, angle B is equal to angle Q. This is also given. So triangle ABC is similar to, now order is very important. Okay, in while teaching congruency also I have told that order is the most important thing. Here also I am saying order is the most important thing. Okay, so let's find the order. Randomly do not write PQR. Okay, we have to find the order. While finding the order, you don't need to look at the triangle. You just need to look at here what you have written. See, angle A is equal to angle R. So A corresponds to R. A first means R first. Okay. Then B corresponds to Q. B middle means Q middle. So the last option is P. So the order is not PQR, rather it is RQP. Here you can write angle postulate. Okay. So now once you get the order, this is very important. Okay. Once you get the order, you get everything from here. You don't need to look at here. You don't need to look at the figures. Now you can check angle A is equal to angle R. Okay. See the figure. Angle B is equal to angle Q. Middle one. Angle B is equal to angle Q. Last option. Angle C will be equal to angle P. Angle C will be equal to angle P. Then what about the sides? They will be proportional. That means you can get from here. Okay. So AB by RQ 1 to 1 2. AB by RQ is equal to BC by QP is equal to AC 1 3 AC by RP. Okay. So the corresponding sides will be proportional. So AB, BC, AC of triangle ABC will be proportional to RQ, QP, RP of triangle PQR. Okay. So once you get the order, you get everything. This is angle postulate. Next postulate is SSS, side. Side postulate was in congruency also, but it was different. It was like this. Okay, in congruency, side postulate was, if three sides of a triangle are equal to three sides of another triangle, then the two triangles are congruent. Okay, but here we cannot say that the sides are equal. So what we will say? we will say they are proportional. Okay. So if three sides of a triangle, if three sides of a triangle are proportional, use the word proportional, do not use the word equal. Proportional to three sides of another triangle, then they are similar. Okay. So let us draw two triangles which will be satisfying this. Suppose A, B, C. P, R, Q. Okay. Suppose three sides of this triangle are proportional to three sides of this triangle. Suppose it is given AB by PR is equal to BC by QR is equal to AC by PQ. This is given. Okay. So we can say these two triangles are similar. So how to write this? In triangle ABC and triangle PQR. Okay, just write this. Okay, just write this. AB by PR is equal to BC by QR is equal to AC by PQ. This is given. So the two triangles will be similar. Let us find the order. You will get the order from here. Okay. You don't need to look at the figure, there will be confusion. Okay. Just look at here while finding the order. The same trick I had given for congruency. You don't need to look at the figure. Triangle ABC similar to. Now you do not have angles. When angles are given, it is very easy to find the order. Okay. But when sides are given, it is not difficult, but it takes a little more time. Okay. So here there are no angles, so we are bound to target sides. So look at the corresponding sides. The first corresponding sides are AB and PR. So the opposite vertices will be corresponding vertices. So which are the opposite vertices? Opposite of AB is C. Opposite of PR is Q. So C corresponds to Q. Okay. C and Q are corresponding vertices. Their positions should be same. So C third, so Q third. Ready? Next, BC and QR. BC and QR. The vertex opposite to BC is A. The vertex opposite to QR is P. So A corresponds to P. So A first means P first. The last option is R. You can find from here also the last option, but you don't need because this is the last option. This is SSS postulate. Okay. Once you get the order, you will get everything from the order. Okay. I'll not look at this, but everything will be correct. Okay. You can check. Just look at here. Okay. I look at here. AB by PR is equal to BC by RQ is equal to AC by PQ. Okay. You can check. Everything is correct. Now let us go for the angles. Corresponding angles are equal in similar triangles. So we can say angle A is equal to angle P. Angle B is equal to angle R. Last is angle C is equal to angle Q. Okay. So from the order you get everything. This is the second postulate. Now let's move to the third postulate. Okay. Now let us move to the third postulate. Okay. I am not erasing the triangle because I will get two triangles again. Okay. Third postulate is, this is the last postulate. SAS. This postulate was in congruency also, but it was different. What was the postulate? In case of congruency, if two sides have included angle, the middle one, the angle between the two sides. Okay. If two sides and the included angle are equal to, if two sides and included angle of a triangle are equal to two sides and included angle of another triangle, then the two triangles are congruent. But in similarity, we can say angles are equal, but we cannot say sides are equal. So what you have to say? If two sides of a triangle are proportional to two sides of another triangle, okay? If two sides of a triangle are proportional to two sides of another triangle and the included angle, means the angle between the two sides, they will be equal, angles can be equal, and the included, do not forget to mention the word proportional, okay, and do not forget to mention the word included, okay, and the included angles are equal, then the two triangles are similar. Okay. So this is the last postulate, SAS, two sides and included angle. Suppose it is given AB by ln is equal to BC by ln, and so two sides of triangle ABC are proportional to two sides of triangle LN, and the included angle. So randomly we cannot choose any angle. You have to take the included angle. AB and BC we have taken. AB and BC we have taken. So which is the included angle? Angle B. Similarly, we have taken LM and LN. So we are bound to take this angle. So if angle A, angle B and angle L are equal. Okay. So and angle B is equal to angle L. This is given. Then the two triangles will be similar. How to write this? In triangle ABC and triangle LMN. Okay, just copy this. AB by LN is equal to BC by LN, given, and angle B is equal to angle L. This is also given. So angle ABC is similar to, now let us find the order. I told you that when angles are given, it is very easy. So target angles first. If there are some angles, B and angles are given, so B will correspond to L. B middle, so L will be middle. L will be middle. No more angles, so we are bound to target sides now. So take the first side, first corresponding sides, AB and LM. Okay. So which vertex is opposite to AB? C. Which vertex is opposite to LM? N. So C corresponds to N. So C third means N third. So which is the last option? not LML, the order is MLN. This is SAS postulate. Okay. Once you get the order, you get everything from the order. So now we will go for the angles. Angle A will be equal to angle M. Means angle A, this angle will be equal to this angle. Okay. Angle B equal to angle L. This was already given, so no need to mention. Then angle C equal to angle N. Angle C is equal to angle N. Okay. Now which are the corresponding sides? AB by ML, it was already given, is equal to BC by LN, it was also given, is equal to the last one AC by ML. Okay. This was not given, but we can find from the order. So these are the three postulates which we are going to use extensively in this chapter. Angle, side, and side angle side. Out of the three postulates, the most frequently used will be the angle postulate. Okay. So now let us go for a theorem. Theorem number 1, which was given by Pythagoras around 2500 years ago. Theorem 1. This theorem was given by Pythagoras. Okay. So the theorem states that the altitude corresponding to the hypotenuse, okay, corresponding to the hypotenuse. Now, if hypotenuse means it must be a right triangle, okay, because hypotenuse belongs to right triangle only. So, corresponding to the hypotenuse of the right triangle divides it, okay, into two triangles which are similar to each other and also to the original triangle. So read it and try to understand. I will show you in a diagram. The altitude corresponding to the hypotenuse. Okay. The altitude corresponding to the hypotenuse. Means we will draw a right triangle. Then we will have to draw altitude corresponding to the hypotenuse. That altitude will divide the triangle into two triangles, two smaller triangles, which will be similar to each other. Okay. Which will be similar to each other, and also to the original triangle, means to the original big right triangle. Okay. So let us draw the figure. I have drawn a right triangle ABC, right angle at B, angle B is 90 degree. So which is the hypotenuse? The side opposite to the right angle, means AC is the hypotenuse. So now I will draw altitude corresponding to the side AC, means hypotenuse AC. So I have to start from B. From B I have to draw a perpendicular on AC. Okay. So let us draw. Suppose this is P. BP is perpendicular to AC. So BP is the altitude corresponding to the hypotenuse AC. According to this theorem, this BP divides the big triangle ABC into two small triangles, means this one and this one. These two triangles which are similar to each other. These two triangles will be similar to each other and also to the original big triangle. Means collectively this triangle, the small triangle, this small triangle and the big triangle, means the three triangles. Here there are three triangles will be similar to one another. Okay, so we are going to prove this. In triangle ABC and triangle ABP, I am taking the big triangle and the small triangle ABP. Okay, small triangle ABP. I am going to prove similarity between these two triangles, the big triangle and the small triangle. Okay, is there any angle common here in the big triangle and the small triangle? Yes, angle A is common. You can see angle A is common. So angle A is equal to angle A which is common. Next, do not take sides common. Okay, in case of congruency you could take sides common, but in case of similarity do not take sides common, because in case of similarity sides are not equal, means may be equal, may not be equal. Okay, sides are proportional, so never take common sides in case of similarity. Remember this important point to remember, never take common sides in case of similarity. Okay, only take common angles. Okay, angles we have taken, one angle we took. Okay, next, any other angle which are equal, you can see angle ABC of triangle ABC is 90 degree. You can see that is equal to angle APB of triangle ABP, because that is also 90 degree. You can see this is also 90 degree APB. So each 90 degree, each 90 degree. Okay, so we got two angles, nothing more we need. Okay, two angles are sufficient, angle postulate. So now let us find the order. ABC is similar to, don't look at the triangle, there will be confusion, look at here. AA, so A means A, angle ABC means B, angle APB means P, middle one. So B corresponds to P, B middle means P middle. So which is the last option? ABP, A and P over, so B is the last option. This is angle postulate. Okay, from this we will get an important result. AB by AP is equal to BC by PB is equal to AC by AB. Okay, because corresponding sides are proportional. Now see, equate first and last. Okay, equate first and last. Actually, we give the order also later on. Equating first and last, AB by AB equal AC by AB. If you erase this one, erase this one. Okay. So if you cross multiply, you will get AB square is equal to AP into AC. Let it be equation 1. Okay, so I am writing here AB square is equal to AP into AC, equation 1. AB square is equal to AP into AC. Okay, AB square AP into AC. This is one result we got. We prove similarity also. Okay. Now let us go for. Again the big triangle and this triangle. Okay, we will prove similarity in the same manner. So in triangle ABC and triangle triangle BCP, this triangle, okay, this triangle. Any angle common? Yes, angle C common. You can see angle C common. Angle C into angle C common. Now any other angle? Sides we cannot take common. Okay, any other angle? Yes. Angle ABC is 90 degree. You can see in the diagram. Angle BPC is also 90 degree. You can see in the diagram. So each 90 degree. Okay. So we can easily get the order. Triangle ABC similar to C corresponds to C. So C third then C third. Then ABC means B. BPC means P. D corresponds to P. D corresponds to P. So remaining option, the last option is B. BPC. This is by angle postulate. Now again successfully we have proved similarity. Okay. So the big triangle is similar to this small triangle and also similar to this small triangle. Okay. So now taking the corresponding sides, AB by BP is equal to BC by PC is equal to AC by PC. Okay, taking the corresponding sides. Now equate these two. Forget this one. Okay. So cross multiply, you will get BC square is equal to PC into AC. Okay. Or CP into CA. Same thing. PC, CP same, AC, CA same. To be able to remember, I am using this, means CP into CA. So first we got AB square, start from A. AB square is equal to AP into AC. Okay. Then we got CB square. I have written BC square, you can use CB square. CB square into CP into CA. Start from C. First we started from A, then we can start from C. So this is the second equation we got. Next our target is to prove similarity between these two small triangles, because according to the theorem, the altitude will divide the triangle into two triangles which are similar to each other. That we have not proved yet. Till now we have not proved. Okay, we have not proved that these two triangles are similar to each other. Okay, so now we are going to prove. But actually we don't need to prove because the big triangle is similar to both the triangles. Okay, the big triangle is similar to both the triangles. So definitely the two small triangles will be similar to each other. Suppose this is called transitive property. Suppose x is equal to y and x is equal to p. Suppose. Okay. Suppose x is equal to y and x is equal to p. Then we can say y is equal to p. Okay, this is called transitive property. Now following this, the big triangle is similar to both the small triangles. So we can say that the two small triangles are similar to each other. We don't need to prove. Just we need to find the order. The order is important. So how to find the order? The first order which we had got, from which we got equation 1, triangle ABC is similar to triangle APB. Okay, this I told that we will need it later. Okay, so this was the first order. What was the second order for the second triangle? Again, triangle ABC is similar to C corresponds to C, P corresponds to P, BPC. So this was the second order. So ABC, ABC. So this will be the order. Okay, this will be the order. So we can write here triangle APB similar to triangle BPC. I have not changed. You can see ABC, ABC. So this will be the order APB and BPC. So this is the correct order. So now let us take corresponding sides. PB by PC is equal to AB by BC. Okay. Let us equate these two. Let us equate these two. So cross multiply we will get PB into PB means PB square. Okay, PB into PB means PB square is equal to AP into PC. Okay, or PA into PC. PA into PC. So start from P. First we started from A, then we started from C, then we start from P. So PB square is equal to PA into PC. Okay. So these are three important equations which we got. Now from these three equations, from these two equations, this is also important, but we will get these two equations to prove that famous Pythagoras theorem. Now what was the Pythagoras theorem? Sum of the squares of the legs of a triangle, or in other words, the square of the hypotenuse of a right triangle is equal to sum of the squares of the other two sides. This was the theorem, Pythagoras theorem. So for this triangle we should get AC square is equal to AB square plus BC square. This is Pythagoras theorem. We will get this from those two equations. So let us use them. So in this triangle, AC is the hypotenuse, AB and BC are the sides containing the right angle. So let us start from here. Okay. AB square plus BC square is equal to, now what is AB square? Look at the first equation. AB square is equal to AP into AC. AP into AC. What is BC square? Look at the second equation. CP into CA. CP into CA. Okay. So we have started from right hand side. Okay. We will get the left hand side. So what is common here? AC, AC. CA, AC, same. So we can take AC common. So remaining is AP plus CP. Okay. Which is equal to AC into, what is AP plus CP? Look at the diagram. AP plus CP is equal to AC. Okay. So this is AC. What is AC into AC? AC square. Okay. So we got AB square plus BC square equal to AC square. AB square plus BC square equal to AC square, which is Pythagoras theorem. Okay. So remember this theorem. So what is the theorem? In a right triangle, the altitude corresponding to the hypotenuse divides the triangle into two small triangles which are similar to each other, means these two triangles will be similar to each other and also similar to the original big right triangle. Okay. So this is theorem number 1. From this theorem, the Pythagoras theorem has been derived. Now theorem number 2. Theorem number 2. Which is called BPT. Sorry, I wrote the short form. theorem. In short, we write, okay, BPT. Okay. In class 9 there was MPT, midpoint theorem. Here there is BPT, basic proportionality theorem. This theorem was given by Thales of which country I don't remember. It was also given long ago, okay, by Thales. So it is also known as Thales theorem. Okay. So basic proportionality theorem or BPT or Thales theorem. Okay. So what is the theorem? It states that the line drawn parallel to one side of a triangle divide the other two sides in the same ratio. Okay, that means suppose we have a triangle A, B, C. Okay. Now suppose if you draw a line parallel to any of the three sides. Okay. Any of the three sides. Suppose I draw a line parallel to BC to intersect these two sides. I have drawn parallel. Okay. Suppose this is M, this is N. So line MN has been drawn to intersect AB and AC and is parallel to BC. Then according to this theorem, these two sides means AB and AC will be divided in the same ratio. That means we will get AM by MB is equal to AN by MC. Okay. We will prove this. So let us prove this. Given MN parallel to BC, to prove AN by MB is equal to AN by MC. So this is the theorem. Okay. Here I am proving, you don't need to prove. Okay. You just have to use it and you have to remember and use it. So MN parallel to BC means AN by MB equal to AN by MC. That you have to use. Okay. So let us go to proof. In triangle AM, N, and triangle ABC, angle A is equal to angle B. You can see the diagram. Angle A is common in both the triangles. Common. Next, angle AMN. This angle should be equal to this angle. Corresponding angles is equal to angle ABC. Corresponding angles. So these two triangles should be similar. Okay, AMN. Let us find the order. A then A. AMN means M. ABC means B. M corresponds to B. M middle means B middle. So ABC. This is by angle postulate. Okay. We prove similarity. Slowly we will move towards this. Okay. we will get AN by AB is equal to MN, this we don't need, okay, AN by AC, AN AB and AN AC, AN by AC. Why? Because corresponding sides of similar triangles are proportional. Now let us take invertendo. AB by AM is equal to AC by AM by in ratio proportion. We have already studied what is invertendo. Invertendo means reciprocal. I have taken the reciprocal. Next, AB minus AM by AM is equal to AC minus AM by AM. Now this is by dividendo. In reciprocation you have studied dividendo means minus. Okay. Look at the figure. What is AB minus AM? AB minus AM is equal to BM. BM by AM is equal to what is AC minus AM? AC minus AM is equal to NC. NC by A. Now again take invertendo, again take the reciprocal. So we get AM by BM is equal to AM by NC by invertendo again, hence proved. So this is the theorem. Okay. If a line is drawn parallel to one side of a triangle, it divides the other two sides in the same ratio or proportionally. This is called BPT. Now the last theorem is converse of BPT. Okay, then this part will be over. The first part is only for introduction. Then I will move to examples. Next is converse of BPT. So here we have studied three theorems. Theorem number 1 given by Pythagoras. Theorem number 2 BPT given by Thales. Theorem number 3 converse of BPT again given by Thales. Three theorems. Okay. So what is converse of BPT? So what BPT stated? Okay, BPT stated that means the theorem stated that if a line is drawn parallel, then it will divide proportionally. Means parallel then proportional. Okay, parallel then proportional. So what will be its converse? Proportional then parallel. Okay. So the theorem is like this: if a line divides two sides of a triangle proportionally. Proportionally means in the same ratio. Then it is parallel to the third side. Okay. Suppose we have a triangle like this: A, B, C. Suppose it is given that AP by PB is equal to AP by QC. Okay, means that line, this line, suppose this line is L, this line divides AB and AC in the same ratio, then it will be parallel to the third side. Then we can say PQ is parallel to BC. I am not proving this. This can also be used, means proved using SS postulate. You will have to prove similarity between triangle APQ and triangle ABC using SS postulate. I am not proving because you don't need. Okay, I proved the BPT. So I hope you have understood the basic concept of similarity and the three postulate and the three theorems. Okay, so thank you for watching.